Whenever my son has friends come over to play, eventually the argument will always come down to who shot who first. And then I'm given a front row seat to a reenactment by 9-year-olds of the scene from Star Wars.
My dead body.
Yes,
I bet you have.
Using infrared and 2 Arduinos, we'll be able to settle this argument forever. The one in my house, I mean. In the movies, Han shot first. For this project, you'll need 2 Arduinos. Here we're going to use an Arduino Uno and an Arduino Decimella, 2 breadboards, 2 piezo speakers, 2 push buttons, an assortment of resistors, 2 IR receivers and 2 IR emitters, an assortment of LEDs, connecting wires, and 2 9-volt batteries with their connectors. A USB Type B cable, also Arduino's software from their website arduino.cc. To begin, we'll be using the Arduino laser tag DuinoTag by J44 Instructable from Instructables.com. We'll be using the basics of J44's instructions, but modifying it a bit to fit our needs. We'll begin by connecting the various input and output pins from the Arduino onto the breadboard so that they can be changed and fixed as we need them. Each of the inputs and outputs are based on simple Arduino instructions that you can find linked in the show notes. Along the edge of the breadboard, the pins are connected lengthwise so that the entire row that's indicated by blue, when it is connected to the ground of the Arduino, the entire blue row will be connected to the ground. The entire red row, when it is connected correctly to the Arduino, will provide this entire row with 5 volts of electricity. Conversely, on the breadboard, each of the rows are connected so that we can connect our buttons, LEDs, lights, resistors, and capacitors quickly to do troubleshooting. I'll connect the 5-volt pin to the breadboard and the ground from this side of the Arduino to the breadboard. And first, I'll attach this push button to the trigger pin, which in our code is pin number 3. One leg of the button is connected to the ground, while the other is connected to the voltage through a pull-up resistor, which is also connected to pin number 3. Follow the link for more details on how the push-button pull-up resistor works. Next, we'll hook up our piezo speaker to get audio feedback from our Arduino laser tag gun. We will connect the piezo speaker to the board and with a connection wire hook the positive side to pin number 4 and the negative pin to ground. Next, we'll connect our indicator LED, which signifies a successful hit. On LEDs, the leg that is longer will go to the positive side. To protect the LED, you'll want to put a resistor in between the LED and the power source of the Arduino. Check out the show notes for a calculator to find out what resistor you need for your LED. We'll connect the positive side of this LED to pin number 7 and ground the other leg. Same rules apply for our IR emitter. Putting in the correct resistor, grounding one end, and using the other end to connect with the resistor. This is the LED that will send our IR signals. I recovered this one from an old remote controlled toy. Next we'll hook up our IR receiver diode. According to the specs sheet, pin number 1 is the signal pin, pin number 2 is ground, and pin number 3 is for voltage. So we will hook up this indicator, hopefully in a place where it does not see its own IR emitter, and register its signals. The receive pin is hooked up to pin 12. I made a mistake here. Turn the IR receiver sideways from the picture above. And the positive and negative are plugged into the positive and negative side of the breadboard. Since I'm running out of space, I am going to connect wires from one side of the breadboard to the other, so it's providing the ground and voltage to both sides of the breadboard. Those are the minimum components to have one working Arduino gun. So we'll hook in our USB cable. Once uploaded, I use the Arduino software to upload the code from the Instructable. The speaker gives a tone letting us know that it is ready to receive information and to send information when the button is pressed. You can see on the Arduino that information is being sent every time that I'm pressing the button. The gun eventually runs out of ammunition and gives us an indication that we've run out. So far, everything's working great. So let's do this again on another Arduino. When you upload the code to the second Arduino, make sure you go into the code and change My Team ID to a different ID number than the first Arduino. If you didn't change the code at all on the first one, you can just change My Team ID to set at number 2. With the code successfully uploaded, pressing the trigger button makes the successful hit indicator light go off, and after 3 hits, indicate that that gun has now been disabled. You can see in the serial monitor of the Arduino software that the Arduino is ready, and when I press the fire button, it indicates that a shot has been fired. And when I press the button on the other Arduino, it shows that a successful hit was done and that 1 point has been taken away from the life on that Arduino. With this argument settled, I'm ready to sit back with my favorite Star Wars movie and a big box of popcorn. Thanks everybody for watching.